All right, welcome to my live stream section. We are starting late today. I'm so sorry. I'm trying to set up my mic. Trying to set up my mic right now. All right. All right, welcome to my live stream section once again. Welcome, and welcome. So today is day 3 of our class. Today is day 3 to the class. Now, when we discuss the concept of chemical bonding, note the fact that another name for chemical bonding is also combination. Another name for chemical bonding is also known as chemical what? Combination. And there's a reason why the concept of chemical combination comes into play. There's a reason why chemical combination comes into what play, giving us sodium what? Chloride. This is a chemical what? Reaction, right? Which is a combination what? Reaction, right? So there's a major reason why this comes into play, and that is what gives us the definition of what chemical bonding or chemical, because they want to attain what? Stability, right? So that's everything you're supposed to know when it comes to the concept of what? Chemical what? Combination or chemical what? Bonding. Now, chemical bonding is based on the concept of electronic what? Configuration. It's based on the concept of electronic what? Configuration. And what is electronic what? Configuration? Electronic configuration is the arrangement of what an element, right, based on their what? Atomic what? Number. So electronic configuration is based on atomic number. Electronic configuration is based on what? Atomic what? Number. So the atomic number of hydrogen, which is what? 1, to calcium, which is what? 20, at least for the first element. So the electronic configuration is based on the concept of what? Atomic what? Number, right? So let's talk about the atomic what? Orbitals. And I think in our last class, when I talk about atomic structure, I tried to lay foundation of what atomic orbital is all about. We say the atomic orbital is a region of what? Space where there's at least a what? 98% probability of finding what? An electron. So when they say 98% probability of finding an electron, that is what we call what? The atomic what? Orbital. So let me check who is online. All right, I have some persons online. You are welcome. I have 2 persons online. You're welcome to my live stream section. It's a pleasure to have you here. You're welcome to my live stream section. So today we are discussing chemical bonding. Please just give me a thumbs up. Please just give me a thumbs up. I will really appreciate if you give me a thumbs up. Give me a thumbs up. Share my videos to your friends. Share if you're a white student. Share my videos to your class group. If you're a JAMB, share my videos to your status, WhatsApp status. Share it to all the groups. Facebook. Share it everywhere. To also come here and get value. And like I said, we are running a series. I'm running a live streaming JAMB expository classes from Monday to Friday till the end of this month. Every Monday to Friday, at least from 11:35, expect that I will be online just like the way I am. On Monday, we talk about atomic structure and we solve some JAMB. The concept of cell, right? We discuss the concept of cells and we also solve JAMB past questions. Discussing chemical bonding, which we are also going to solve past questions. But as usual, we start with the introduction of the class, of what the topic is all about, before we start moving straight to the past questions. So we solve this first. We try to know what chemical bonding or chemical combination is all about before we move on to the concept of what the past questions, because this topic is very, very important when it comes to JAMB. So I say this is what an atomic orbital, where there's a region of space where we find a 98% probability of what? An electron. So the major reason elements undergo what? Bonding. It's because they want to attain stability, right? Elements undergo combination because they want to attain stability. They want to attain balance. They want to attain an octet state, and they want to attain a duplex state. So this is a major reason elements undergo the concept of what? Chemical what? Combination. They undergo chemical combination because they want to attain what? Stability. They want to attain what? Balance. They want to attain this octet state, or they want to attain what? A duplex what? State. Right? Remember, in the field of electrons in the atomic what orbitals, right? The innermost electron, the innermost what orbital, maximum of what 2 electrons. 2 electrons is known as what the duplet what state, which is, for example, which is the helium, right? So helium is what balance, which is the what duplet what state. Then others, which is the atomos shell, must contain what 8 electrons, right? Which are singly filled before what pairing what occurs, right? So this is just how what it is. So this is the major reason element undergo or involve themselves in the concept of what chemical what bonding or chemical what. Now the next thing we have to talk about is the types of this chemical combination. So we say types of chemical what combination. Say types of chemical combination. So you say types of bonding or chemical what combination. So basically, we have two main types of chemical bonding. We have two main types of what chemical bonding. We have number one, which is the what electrovalent. We have number one, which is the electrovalent bond. We have the electrovalent bond, and we have the number two, which is what the covalent what bond. But now the covalent bond has another type of what bonding. There's another type of bonding associated with the covalent what bond. So a lot of some people say we have three main types, some people say we have two main types. But at the end of the day, we have the electrovalent bond, we have the covalent bond. The third is what we call the coordinate covalent bond. We call it the coordinate covalent bond. Because you see having what covalent, right? But this one is a special type of covalent bond, so we are going to talk about it. The coordinate covalent what bond, or what is known as what the dative what bond, right? The dative what bond. So this you can say are the three main types of what chemical what combination. So we want to talk about the electrovalent bond, talk about the covalent bond, and we talk about the coordinate what covalent what bond, hitting on the main things, the main what you are supposed to do now as you are preparing for what exams, right? So that is what we are going to discuss now. Electrovalent bond, right, is a type of chemical bonding that involves a transfer of what electrons. So let me clean. This involves the transfer of electrons. This involves the transfer of what electrons. This involves the transfer of what electrons. So what this means is that there's going to be a giver and a receiver what relationship, right? So the major reason elements, right? So the major reason element undergo combination or bonding to attain stability. And I say the first one is the electrovalent or bonding. I say this one involves the transfer of what electrons, right? So what I say involves the transfer of electron, it is what a giver receiver what relationship, right? It's a giver receiver what relationship. And how this works is that if let's say I'm a student in a school, right? And they say we should pay 3,000 naira. They say we should pay 3,000 naira, for example. And I have we should pay 3K. And I have Mr. A have what 4K, and Mr. B has what 2K, right? And they say we should pay what 3K. What is going to happen there is that at this point in time, Mr. A is actually what balanced, because Mr. A, now what happened here is that Mr. A actually have what more than, right? Mr. A actually have what more than the required amount of what money, which is what 3K. That means Mr. A have the tendency of giving out what 1K. So now Mr. B will come and meet Mr. A and say, please, you have 4K, me I have 2K, and they say we should pay 3K. Please, can you help me with 1K? Mr. A will say, why not? If I give you if I transfer my 1K to you, I will also be balanced, and you will be what balanced. So that is how Mr. A will transfer what 1K to what Mr. what B. He's going to transfer 1K to Mr. B. So one is going to give you what 3 what K, and this guy here is going to be left. This guy is going to also have what 3 what K. So at this point in time, they are both what balanced, because Mr. A will be able to pay his or her money, and Mr. B will also be able to pay what his what money, right? So at this point in time, you notice that there's a transfer of electrons, right? So the element that transfers these electrons, the element that transfer this electron becomes what? Electropositive. The one that transfer, right, becomes what? The one that transfer, the one that transfers becomes electropositive, while the one that receives becomes electronegative. So there's no rocket science when it comes to the concept of what? Electronegativity and electropositivity. There's no rocket science. All right, thank you so much for your thumbs up. All right, so thank you so much. Let me see. I have some students on WhatsApp. I need to share my class to them. I don't know whether they are online. So please just give me some time. Let me just share this class to my WhatsApp group. Coming. All right, so I'm back. So my lights just went off. All right. So we say electrovalent bond, right? Is the type of bonding that involves the transfer of what? Electrons. And we say the element or the one that receives the electrons, right, becomes what? Electronegative, and for these electrons become positive, right? So we are going to be giving a very simple example. We are going to be giving a very welcome back. Thank you so much for supporting me. Your presence means a lot. Yes, thank you so much for supporting me. Your presence means a lot. Just spending time to watch my videos, my live stream means a lot to me. All right, thank you so much. Please subscribe to the channel, share my videos to your friends, tell them to subscribe. Thank you so much. I really appreciate. So we say type of what? Electrovalent what? Bond. Remember I said it involves a giver and a receiver what? Relationship. So what is going to happen here is this. There's a popular there's a popular compound we use, right? Popular example of electrovalent bond is sodium chloride. Is sodium what? Chloride. Now, remember I said the concept, this arrangement, right? This arrangement to understand the concept of stability stems from what? Atomic number. Remember when I said it, right? Electronic configuration, which is derived from atomic what? Number. So now what is the atomic number of sodium? So we have hello Helen, little baby, coming never of our father knew before. Hello Helen, little baby, before coming never offend father knew. Now, so sodium is 11, right? Father knew. Now, Maggie, right, chlorine is what? 17. Right, so this I'm just trying to get the first 20 elements, the atomic numbers. So we have sodium to be 11 and chlorine to be what? 17. So let's represent this using the concept of what? Electron what? Configuration. So we have sodium here, 11, right? We have 2, 8, 1, right? We have chlorine 17 to be 2, 8, 7. Remember on Monday when I said the arrangement, the K must contain 2 and the LMN was supposed to contain what? 8, 16 and the rest, but we tend to what? Make it to be what? 2, 8, what? 8, right? 2, what? 8, 8. So at this point in time, this is 2, 8, 8. That is how it was supposed to what? Be. By this point in time, we are having sodium here to be what? 2, 8, 1. And we are having chlorine here to be what? 2, 8, what? 7. So let's use the atomic orbitals. Let's bring in the concept of what? Atomic what? Orbital. Let's bring in the concept of what? Atomic what? Orbital. So the innermost orbital must contain a maximum of 2 electrons. 1, 2. Right? So we have 2. We are working on sodium now. We have 2. We have 8. 1, 2, 2. 1, 2, 1, 2. Right? We have 8, which is 10. And we have what? 1. This is for what? Sodium what? 11. Plus, now let's do for chlorine. All right, so we have innermost 2, We have 1, 2, 1, 2, 1, 2, 1, 2. This is 10, right? And 7, right? All right. So this is what 2 plus 8 plus 1, and this is what 2 plus 8 plus what 7, which is what 17 and what 11, right? So this is for what chlorine, which is what 17, right? So at this point in time, let me clean this. So at this point in time, you find that chlorine, right? You find that chlorine just needs one electron here. Chlorine just needs extra one electron here. Right? Chlorine just needs this extra one electron for it to be what? Balanced. That is why chlorine will now run and go and meet what? Sodium. Say, oh, sodium, let's go into combination. If we go into combination, you give me one of your electron, I'm going to be balanced, and you two are going to be what? Balanced. Sodium will now say, oh, are you sure? Now say, yes, I am sure, 100%. Okay. Let me transfer my electrons to what? You. Now, sodium will now transfer this electron, this one in its what? Outermost shell towards chlorine. Yeah. Now, at this point in time, sodium will now be what? Balanced, because this electron will no longer be here. So sodium is going to be what? 2, 8, and chlorine is going to be what? 2, what? 8, what? 8. So at this point in time, sodium is transferring one electron toward chlorine. So we have sodium to be what? Plus, and we have chlorine to be what? Minus. This is also the concept of what? The valency, where I say when we talk about the concept of valence electrons, we say valence electrons are the electrons in the what? Outermost what? Shell. So the valence electron of sodium, the valence electron of sodium here is what? 1. The valence electron of sodium, the valence electron of sodium is what? 1. That is the valence electron of what? Sodium. Now the valence electron also determine the what? The group, right? So this sodium is in what? Group what? 1. So you say group what? 1. Sodium is in group what? What is the period of sodium? Period. The period is the number of what? Shells. So we have 1, 2, 3. Sodium has what? 3 what? Shells. Now let's check out for what? Let's check out for what? Chlorine, right? Before it got actually this one. So chlorine is chlorine is a member of the halogens, right? Chlorine is a member of the what? Halogens. So valence electron of chlorine is what? 7. Group what? 7, which is a what? Halogens. And what is the period? It has what? 3 what? Shells, which is what? It falls under the what? The third what? Period, right? So that is just it when it comes to the popular concept of what? Ahmed, you prosper. You are welcome. I'm happy that you actually got something here. Thank you so much. You are welcome. Please subscribe to my channel, Prosper. Ahmed, you prosper. Just even we talk about the concept of what period, although I am not going deep into this. But when we talk about the periodic table, we are going to be talking about the group, the period, the trends, right? We are going to be discussing electron affinity, electron negativity, the ionization energy, and the rest, right? So atomic radius. So we are going to be discussing in detail when we talk about the periodic table. But for now, we are just focusing on what? Chemical what? Bonding. And sodium plus chlorine giving us what? Sodium what? Chloride, which is our what? Common salt, table salt, the one we use to what? Cook what? Food, right? So let's move on to the second type of what? Bonding, right? Let's move on to the second type of what? Bonding. Now, the second type of bonding is known as a what? Ordinary covalent bond. The covalent bond. We have the word covalent what? Bond. Now, the covalent bond involves what? Involves sharing of electrons. It involves the sharing of what? Electrons in order to what? Attain what? Stability. Mostly common in what? Carbon what? Compound. Mostly in what? Carbon compounds. mostly in what? Carbon what? Compounds. We also have oxygen. Oxygen also undergoes the concept of what? Oxygen also undergo the concept of covalent what? Bond, right? Giving us what? Our what? O2, right? Because they are not what? Balance. So they tend to what? Share. They can either share with another element or they also share with their what? Self. Water also exhibits the concept of what? Covalent what? Bonding. Water, that is H2O, also exhibit the concept of what? Covalent what? Bonding. Now, I didn't talk about the properties of electrovalent bond. I'm going to discuss about when we start solving past questions. Let me check. I have my past questions here. So, sorry. So when we start discussing it, we are going to see question relating maybe to the properties, and from there we can actually get to list the properties of a covalent bond and electrovalent what bond. So this is for covalent bond. Covalent bond involves the sharing of what? Electrons. You are not balanced, I am not what? Balanced. Let's go into what? Let's go into what? Chemical what? Bonding, or let's go into chemical combination in order for us to be actually what? Balanced. Then we also have the last covalent, like I said, we have electrovalent bond and we have covalent bond. Right now, covalent bond is divided into two. We have the ordinary covalent bond, which I say involves the sharing of what? Electrons. The equal sharing of what? Electrons. Right? So it involves, even though it does not involve equal sharing of electrons, but at the end of the day, there's what? A sharing of electrons. Unlike the another covalent bond, which is known as the coordinate covalent bond. The coordinates covalent bond. Now, this one, the coordinate covalent bond, is also known as dative. So it's a dative bond. So this is a special type of covalent bond. This is a special type of covalent bond. That involves the presence of a lone pair electron. Electron. So most of these we are going to go deep when we start solving. So I think I have been able to that is we can need bound. That because all right. So let's see how we can solve questions now based on the concept of what? Chemical what? Bonding. So we are going to be solving questions. Sorry, I was getting caught, so I had to. So let's see how we can start solving questions. I think I have done justice to the concept. Abumoni.